Hey, 8th grade. So our learning target today is I can identify and solve non-proportionate problems using table graphs and equations. You should be on page 28. So what's going to happen in page 28 is you're going to be given a non-proportionate problem, which means it does not go through the origin 0, 0. The beginning amount is not 0. It's something other than 0. So you're going to actually be working backwards from the graph to get information in the table in the equation. So to start here, you're going to basically, I want you to write these 5 notes down to start. So go ahead and copy these somewhere in the white space, maybe perhaps on the top of the paper. So step 1, 2, 3, 4, 5, maybe up above where it says learning target 3. Go ahead and copy these notes down. I'll wait for you. Go ahead. So everybody should be copying down those 5 steps up maybe in the white space in the front. Okay. If that's too fast, go ahead and pause that video. Otherwise, we're going to move on. So those are your 5 steps. We're going to write down all friendly points in the table. I'll explain what that means in a second. You're going to count your slope, your rise, run. We'll find the y-intercept. We'll write the equation, and then we'll check to make sure everything is working out there. So here we go. Learning target, back to the learning target table graph equation. So here is our what I mean by friendly points. So step 1, the friendly points. We cannot sleep in the hallway. You have to sleep in a hotel room. So here is a friendly point. We have this as a friendly point, friendly point, friendly point, friendly point. I want you to take a look at my screen right now and make sure you understand that those are the 5 friendly points because they meet at an intersection. They're at nice crossing points. We write down all of those. We don't have any labels on these graphs, so we're not really sure what the real world examples are here. Okay, so as I start to solve then, I have this first point here, 0, 3. We're going to write them all in our table. 2, 4, 4, 5. Might start to see kind of a pattern there. 6, 6. And it looks like we also have 8, 7. Looks like the x coordinate is changing by 2s and the y coordinate is changing by 1s. That's step 1. So if I go back to the notes I asked you to take, step 1, write down all friendly points. We just did that. We had 5 friendly points. Step 2, we're going to count slope, which means rise, run. So going back to the graph, we're going to rise, run to get the slope. Here's my hotel room, friend's hotel room. We're going to ignore the other hotel rooms. We only need 2 for slope. We are going to rise 1 unit, and we are going to run 2. So my slope is 1/2. The y-intercept is a place where the y-axis crosses the graph. So in this particular case, we have our y-axis. Our y-axis hits the graph right here at 3. So our y-intercept then is 3. So my equation is y equals mx plus b. So we would go ahead and say our y is a stop sign. My slope is 1/2. X is a stop sign. And my b is 3. My equation is y equals 1/2 x plus 3. We are done. That's what you're asked to do is work the graph backwards, pull it into a table, pull it into the equation. We are done. Now, if you're using a decimal here of 0.5, I'm okay with that as well. If you prefer to go decimal on that and substitute in, that's okay. Instead of a fraction, if you feel better about that, I'm okay with that. All right, next problem. Again, working backwards. The 5 steps are listed below. Find friendly points, rise, run, find the b, write equation, and then the check, just make sure everything seems okay. All right, so xy. We're going to go ahead and find some friendly data points. So we'd say this one looks good, that one looks good, that one looks good, that one looks good. Go ahead and find those same 4 data points, please. Okay, as we start to solve, we're looking for some data points to put in. So watch your scale here. We're scaling by 2s over here. Every line is worth 2. Be very careful about that. So if I'm rising from here to here, I'm actually rising up 4 units. That's not where I meant to put that. I meant to put the data points in the table. My fault. Let me start over. 0, 2 is the first data point here. This is 1, 6. Go ahead and catch up. If that's too fast, go ahead and pause that video. We have 2, 10. We have 3, 14. So those are my XY pairs. So for my slope then, I'm going to rise from here to here. Now you can use the formula too if you prefer to use formula. You're more than welcome to do it, but I'm going to run it today. That's a rise from 2 to 6, which is a rise of 4. And I'm going to run over 1 unit. So run is 1. Slope is then 4. For my y-intercept is the place where the y-axis hits the graph. I'm going to erase all this stuff because it's getting a little bit messy in here. So my y-intercept is the place where the y-axis hits the graph. So it hits it here at 2. So my y-intercept becomes 2. So my equation then is y equals y stop sign, slope is 4, x stop sign, plus y-intercept is 2. Equation is y equals 4x plus 2. So there's our equation there. Moving on, we have 4 more to go, looking for the slope, y-intercept, and the equation for all of these problems. Looking for some friendly points. This one doesn't have as many. We have a nice one here. We have a nice one there, and I believe we only have 2 nice data points, so that's all we are going to go with. Reminder that you only need 2 to get a slope, so we're fine with 2. 1 would be tricky. Our data points then are 0, 4, and we also have a data point of 5, 5. So those are my 2 data points. That's plenty to get a slope. Reminder, you can go y2 minus y1 over x2 minus x1 if you prefer. I'm going to run it. Watch your scale. We're scaling on the y-axis up and down by 1s. We're scaling on the x-axis 1 by 1s. So we're going to rise 1, and we're going to run 1, 2, 3, 4, 5. We're going to rise 1, run 5. Slope is 1/5. The y-intercept is the place where the graph crosses the y-axis. So here's our y-axis. There's my graph. It hits right here. The y-intercept then is 4. So my equation then is y stop sign, the slope is 1/5, x stop sign, and the y-intercept is 4. So my equation is y equals 1/5 x plus 4. Y equals 1/5 x plus 4. Okay, box number 4. Pick some friendly data points off that table. We have a nice data point here. We have a nice data point here, and we have a nice data point there. Go ahead and identify those same data points. Take a peek at that. Make sure that makes sense to you. Why they're nice. They have to meet at a nice intersection. All right, so our data points then would be 0, 1, 4, 4. Watch your points here. Watch your scales. 8, 7, it looks like. So our data points are 0, 1, 4, 4, and 8, 7. My slope then, rise and run. Really be careful on the rise run scales here. Otherwise, of course, you can use this formula in the table. But when I rise, I'm going to go up by 1s here. We're going from 1 to 4. That's rise is 3. When I run, watch the scale. It's going by 2s down here. So that's 2, 4. So my run is 4, which gives me a slope of 3/4. Now, if you prefer to use the decimal of 0.75, that is fine as well. Writing my equation then would require me to have a y-intercept first. So when I go to find the y-intercept, it's the place where the graph crosses the y-axis. That happens right here at 1. So my y-intercept would be 1. My equation then is y equals mx plus b. My slope is 3/4 x plus, and my y-intercept is right here at 1. There's my equation, y equals 3/4 x plus 1. Three-fourths x plus 1. In number 5, xy table. We have this xy table. Our data points, we go ahead and find our data points. They're here and here and here and here and here and here. We have plenty of data points there, x and y. All right, so as I look at the data points, I have 0, 15. I have 1, 20. I have 2, 25. 3, 30. If I'm going too fast, go ahead and pause that video. This looks like 435. And 5 looks like it's going to be 40. Go ahead and catch up there. 540. Okay, so as I start to solve then, our situation would be to find the slope. As we look at the slope, we are going to rise up 1 unit. Our rise is 5. Our run is 1. Rise is 5, run is 1. Because these are going by 5s. This is only going by 1 down here. Slope is 5. Again, you can use this formula if you prefer. If the rise run is confusing because of the scale. On the y-axis then, I have a y-intercept on my y-axis here, and that's hitting right here at 15. So the y-intercept is 15. So my equation then is y equals, my slope is 5, x plus 15. So my equation is y equals 5x plus 15. Go ahead and write that equation. If that was too fast, go ahead and pause the video. I'll try to slow down for a second so you can catch up. Everybody go ahead and try to catch up. All right. All right, moving on to the next problem. All right, so then we have 0, 4 here. We have another data point here. We have another data point here. So we have 3 nice, friendly, what we call friendly data points there. So our data points would be 0, 4. We have a data point of 15. Watch the signs here, or watch our scales here. 15, 6. Right 15 up 6. And then we have a data point of right 30 up 8. Finding the rise run for our slope. As we find the rise run for our slope, we're going to rise up this far. From 4 to 6 is a rise of 2. We're going to run 5, 10, 15. So my slope is 2/15. For my equation then, I need the y-intercept before I can write. I have the slope, but I need the b. So my y-axis is here. My y-intercept is right here at 4. My equation, let me rewrite that. I'm having trouble with that highlighter. My y-intercept is right there at 4. My equation then is y equals mx plus b. So we have y stop sign. My slope is 2/15. We have x stop sign. My y-intercept is 4. So my equation is y equals 2/15 x plus 4. Now, if you want to put that as a decimal, you can. It's kind of an ugly decimal, but you definitely can use that as your decimal if you prefer. Okay, so for our summary today, we have a couple of things to just remind you of. Remember that you're looking for friendly points. Make sure you find friendly points. You need 2. It's great if you find more, but you have to find 2. And remember that we're then going to write in y equals mx plus b. Keep in mind that the y-intercept, here's our y-axis, here's our x-axis. This here, anywhere on here is known as our y-intercept. That's our b. All right, guys, so that is how we work backwards in our equation work. Your homework for tonight is to do page 29 and 30, which are some real-world examples. You should be able to handle the review on that. Some real-world examples. Have a fabulous night, 8th grade.